So there was a problem fairly similar to this on the skills check. We know in number 6, part B, that segments ST and QR are parallel, so I'm going to mark them with parallel markings. And that creates for me two triangles in the picture. We have this little triangle up here, and then we have the larger triangle. So let's look at those two triangles separately. So if I draw these two triangles off to the side, so up at the very top here, this is P. For the little triangle, this is S, and this is T. ST has a length of 9, and PT has a length of 5. If I'm looking at the larger triangle, we still have P up at the tippy top, but now these two bottom vertices are Q and R. And based on the picture, we know that segment QR is 3x plus 7. Then we still need to find PR. This length goes all the way from point P down to point R. So I have pieces that I need to put together. I need to put this 5 together with the 16 plus x to get that full length. And I've got some like terms that I can combine here. I can combine the 5 and the 16. What does that give me when I combine those together? 21. So that would be 21 plus x right here. So this side is 21 plus x. You have to add those two pieces together. This is the side of the little triangle. This is not a side of a triangle at all. This is just a part of a segment here, part of PR. So we have to add those pieces together to get that entire segment. Once we add those together, then we can set up our proportions. Remember, we want to match up corresponding pieces, corresponding sides. So 9 and 3x plus 7 would make a fraction together. It does not matter which one I put on top. So I'm going to put 3x plus 7 on the top here, over 9. And then my other fraction is going to have the 5 and the 21 plus x. Those are corresponding sides. Since I put 3x plus 7 on the top of the first fraction, and that came from the big triangle, 21 plus x has to go on the top of the second fraction because it also comes from the big triangle. So 21 plus x over 5. And then we multiply to get rid of our denominators. We do one at a time. Which denominator would you guys like to eliminate first? The 5. Sounds good. So to eliminate a denominator, we multiply both sides by that denominator. On the side where we have a matching denominator for what we are multiplying by, those two pieces cancel out, and it does nothing to my numerator. My numerator is left alone. So this would be equal to 21 plus x. Yesterday I noticed on the skills check that there were several people that were canceling it with the denominator, but then also distributing. You can't do that. If it cancels, it's gone. It cannot distribute if it cancels. Over on the left-hand side, we're multiplying by this 5, and my denominator does not match. So this 5 distributes to both parts of my numerator, and that means I have to multiply both parts of the numerator by 5. So 5 times 3 would give me 15x plus 5 times 7, which would be 35, still over 9. Then we need to get rid of our other denominator of 9, so we're going to multiply both sides by 9. That's going to cancel my denominator out. Remember, that does nothing to the numerator. If it cancels with the numerator is unchanged. Nothing happens to the numerator. 15x plus 35 is equal to, over here, this 9 has to distribute to both of these pieces. This is why it's so important for you to put parentheses around everybody, because it's not 21 plus 9x. That would be absolutely incorrect and would lead to the wrong answer. You have to do 21 times 9, which is 189, plus x times 9, which would be 9x. And then from here, we need to get our x's to the same side, so I need to make it cancel on one side. So I'm going to subtract 9x to make it cancel on the right. If you do it to one side, you do the exact same operation to the other side. So I have 15x minus 9x, which gives me 6x, and then plus 35 equals 189. Then we subtract 35 from both sides. I get 6x is equal to 154. And then we divide both sides by 6. Do we get a whole number? No, that does not mean that you made a mistake, though. X comes out to be 25.6 repeating. What else would you guys like to see? Which one? Number 5, absolutely. So number 5, which is just above this one, says John is standing near a lamppost and wants to know its height. He realizes he's formed similar triangles and can use a proportion to solve the problem. John is 6 feet tall and his shadow is 8.5 feet long. That's the very first thing I'm going to draw. All right, so here's John, 6 feet tall. His shadow on the ground is 8.5 feet. This is a right triangle right here. At the same time, the lamp post casts a shadow that is 20 feet long. So we have a lamp post here, a much longer shadow, and it's making a right angle with the ground. So the shadow now is 20 feet long. And we do not know how big the lamp post is. But we can match up corresponding pieces. What is a pair of sides that would be corresponding between these two triangles? 8.5 and 20. Yes, the shadows. So I can make a fraction with 8.5 and 20. Does not matter which one you put on top and which one you put on bottom, as long as we stay consistent with our next fraction. So the shadows make a fraction together, and what other two sides would be corresponding then? 6 and x. Which one would I have to put on top since I put 8.5 on top of the first fraction? 6 has to go on top here. So 6 over x. And now we're going to solve this for x. Let's start by multiplying by our variable. Multiply both sides by x. Cancels out on the right-hand side. So on the right-hand side, I only have that 6 remaining over there. On the left-hand side, it only multiplies to my numerator. So I would have 8.5x over 20. And then I multiply both sides by the other denominator of 20. Cancels my denominator here on the left. So on the left, the only thing I have remaining is 8.5x, bless you. And over on the right, we do 6 times 20. So I get 120. And then we divide both sides by 8.5. This does not come out to be a nice, pretty whole number. It is about 14.118 if we round that to 3 places on the calculator. If you wrote 14.12, I would be fine with that. Please don't round it to just 1 decimal place unless that's what the directions say. Give me at least 2 decimal places. 3 is better. Don't give just 1 unless the directions say to give just 1. What else would you guys like to see from the review? Yes. You said 13? All right, so 12 and 13. Let's go look at those two. We'll do them in numerical order. So 12 first and then 13. There we go. If triangle RST is similar to triangle EFG, SH is an altitude of triangle RST. So this is an altitude right here. And FJ is an altitude of triangle EFG. So this would be an altitude right here. ST is 6. SH is 5. FJ is 7. We want to find FG. Since I don't know how big FG is, I'm going to call that X. This is one of the things that we learned right at the end on Friday and then on Tuesday when we were virtual. Special parts of similar triangles. The altitudes are a special part, and so we would match the altitudes together to make a fraction. So I'm going to have a fraction that is either 5 over 7 or 7 over 5. I'm going to do 5 over 7. And then we need to match up the corresponding sides, which would be the 6 and the X. Because of the way I set up the first fraction, what has to go on top? 6 has to go on top over X. So now I'm going to multiply both sides by my denominator of X. Cancels with the X on the right, multiplies only to the numerator on the left. So I have 5x over 7 equals 6. Then we get rid of our second denominator. We're going to multiply both sides by 7. Cancels the denominator on the left. So I have 5x equals, what is 6 times 7? 42. And then we divide both sides by 5. It doesn't come out to be a whole number, but it does come out to be pretty. This one is 8.4, no rounding needed. I'm only giving 1 decimal place because that's all that was showing on the calculator. All right, so there's number 12. Number 13. Use the figures to determine which postulate or theorem can be used to complete the statements below. So when we're talking about a postulate or theorem here, we're going to be talking about angle-angle similarity, side-side-side similarity, and side-angle-side similarity. Those will be the reasons that we use for why different triangles are similar. All right, so part A says triangle SRT. Let's go find SRT. Here's triangle SRT. Is similar to triangle POQ. Let's go find POQ. Right here is POQ. By what? And we have to show work to support our answer. Could I use angle here? No. Could I use side here? If I came in and I found this angle right here and it matched this angle, then I could use side. But without this angle right here, I can't use side because these two angles are corresponding and we have to match up the corresponding angles. But if I found this angle over here, which I could do because I know the other two angles, then we could try to use side. Could I use side without any extra work? Yes, we can use side. We know all three sides on triangle POQ, and we know all three sides on triangle SRT. So we're going to see if these sides are proportional, which means I have to match smallest to smallest and biggest to biggest. What's the smallest side on POQ? 9. What's the smallest side on SRT? 6. So I'm going to match up 9 and 6 and make a fraction. So I'm going to do 9 over 6. And I want to know, is that equal to? So equal sign with a question mark because I don't know right now. Is that equal to? Let's match up the medium-sized sides. Which one is the next smallest here? 12 is the next smallest. And what would that correspond to over here on SRT? 8. So 12 and 8 are going to make a fraction together. 12 over 8, because I already put triangle POQ all over triangle SRT in my other fraction. Is that equal to? And now I'm going to match up my biggest sides, which would be the 13.5 and the 9. So 13.5 over 9. And now we're going to simplify each one of these fractions and see if they come out to be the same. What is 9 divided by 6? 1.5. 12 divided by 8? 1.5 again. So those sides are proportional, but we still have to know about this last pair of sides. What is 13.5 divided by 9? 1.5 again. So since we looked at the 3 pairs of sides, I would say that these two triangles are similar by side, similarity. Don't forget to put the squiggle at the end. I need your head up, dear. Please pull your review out. All right. Part B, still looking at triangle SRT, but now we're also going to look at triangle VUW. So SRT stays. VUW is what we're going to compare it to. Can I try side again? No, I don't have all 3 sides on VUW. Could I try for side? Over here I could. Yeah, I don't have 2 sides over here on VUW, so side is also out, which leaves me with which one is the one it has to be. If it's gonna show similarity, it has to be angle. That's my only option. My problem, though, is that I see these 2 angles that correspond. So I could say angle T is congruent to angle W. Do I have another pair of matching angles? If I do extra work, and I think that's what we're going to have to do. Last time we got away without doing the extra work because we could do side. Here I'm going to have to do some extra work and find the 3rd angle on one of these 2 triangles. Do you guys want to find angle S or angle U? It doesn't matter. U? Sounds good. All right, so we're going to find angle U. So the measurement of angle U plus the measurement of angle V plus the measurement of angle W. What do all three angles have to add up to? 180. All right, so we have the measurement of angle U plus angle V, which is 70, plus angle W, which is 50. And that has to add up to 180. What is 70 plus 50? 120. So the measurement of angle U plus 120 degrees equals 180 degrees. And then I'm going to subtract 120 degrees from both sides. And that gives us what for angle U? Angle U is 60 degrees. So I'm going to add that to my picture. And now I can look at these two angles, angle U and angle R. Angle U is congruent to angle R. And so now I have enough information to say that these two triangles are similar by angle-angle similarity. When it says to show work to support my answer, I either have to show that the proportions came out to be the same, or I have to show and state explicitly which are the pairs of angles that are congruent. Or if it's side angle side, I'm going to have to do both of these pieces. I'm going to have to show one pair of angles congruent and two pairs of sides proportional. Let's look down at C. For C, we're still going to keep triangle SRT. But now we're going to compare triangle SRT to triangle MLN. Triangle MLN would be this one over here. Could I use side, side, side here? No, I'm missing this side, so I can't use side, side, side. Could I use side, angle, side? Yes. Here's a pair of corresponding angles right here. I could say that angle L is congruent to angle R. And then I would have to match up my corresponding sides. So 12 and 9 would match up. 18 and 13.5 would match up. Remember, I do biggest to biggest, smallest to smallest. So I would have to show that 12 over 9 comes out to be exactly the same as 18. Oh wait, I'm looking at the wrong triangle here. My apologies. I drew my lines to the wrong thing. All right, let's try that again. 12 would match up with what on the blue triangle? 6, sorry. So 12 and 6 would have to make a fraction. So 12 over 6. I want to know, is that equal to, what other two sides would have to correspond then? 18 and 9. So 18 over 9. What is 12 divided by 6? 2. And 18 divided by 9? 2. So we can say that these two are similar by side angle side similarity. We already said we couldn't use side 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 similarity, but could I use angle angle similarity? Yes, we could have also chosen to use angle angle similarity because we have a 50-degree angle here and a 50-degree angle here. So we could say that angle L is congruent to angle R, and angle N is congruent to angle T. So that would allow me to use angle angle similarity. Got about 5 minutes left. That's enough time for 1 or 2 more problems, depending on the length. What else would you guys like to see? 15? Absolutely. 15 is down at the very bottom of this page. It's the last problem on the review. It says that K, M, and P are all midpoints. So K is a midpoint, which means JK and KL are congruent. That's something that I could write down. Segment JK is congruent to segment KL. Said that M is a midpoint. Which means LM and NM are congruent. And then P is also a midpoint. Which means JP and PN are congruent. I could write all of those pieces down. What would we call these segments in here that are joining the midpoints? What do we call segments that join midpoints? I can't call it a midpoint because it's not a point. Mid-segment. So all 3 of those are mid-segments. Mid-segments are always going to be parallel to the side that they do not touch. So that means that KM right here is parallel to JN. KM is parallel to JN. And it's also half of that whole segment. Well, if JP is 7, how big is PN? If JP is 7, how big is PN? 7. So how big is this whole side then? That whole side is 14. And our mid-segment, KM, is equal to half of side JN, so it's half of 14. Can you see any other statement that I could make that would be kind of like that? Anything else that I could say? What'd you say? You said LN? LN's 23. So how big would LM be then? What is M again? It's a midpoint. So how much of this whole side is LM? 11.5, or half of it, yes. LM is equal to half of 23, or you could write LM equals 11.5. That would be the exact same thing. What's another statement that we could make here? Are there any other segments that we know the size of? Yep, we know this mid-segment PM. I know that that's 10. How would that relate to this side over here? How many mid-segments this big fit over here? 2. So I could do 2 times 10 equals K or JL. 2 times 10 equals JL. The bell did go ahead and ring. What I want you to do for the rest of this problem is come up with 5 more statements that could be made here. If you need help, you need ideas, you can look on the answer key, which is posted in Canvas. Down at the very bottom of today's Canvas page is the Module 8 Test Review answer key. You can find that right here with all of my work. So if we go all the way to the end, there we go. You can see I have 10 statements there that can be made. You are welcome to use those as a jumping off point if you need help coming up with more statements.